Okay, hello, welcome to my channel. My name is Solo Anch, and in this video, we want to solve this problem right here. So we want to find the sum x to the fourth power plus y to the fourth power plus z to the fourth power given these three equations. All right. So before we jump right into this, let me react to the question I posted on my Facebook page. I the best got it right. Okay, it was an algebraic equation involving some factorial and then some quadratic on the right. So what you have to do is to factorize the quadratic and then cancel common factors after expanding the factorial on the left. And then with trial and error, given that when we use factorial notation, okay, we want non-negative integers for the variable that is x factorial. So x should be non-negative integer based on the definition of the factorial. And then from there we're able to get 3 as a solution. So yeah, that's it. Though there's a little thing there in the solution, you went ahead to look at other solutions, but that would be a case where the factorial has been extended to some gamma functions, which will include every real number except the negative integers. But the question didn't need all of that, but so that means 3 is the only solution to the problem. So shout out to ID Best on that. Okay, let's continue over here. Okay, so we're given these three equations. We're going to use these three equations as hypotheses. In other words, these are the assumptions, and then we want to use this, find the value of this as a result. So whatever we'll be doing will be center on these three equations, all right? So let's see what we get. We want x to the fourth power. So how do we get some fourth power from these equations, all right? So that should be your target. Well, to get power 4, well, we can just start off with equation 1. We can just say, well, raise both sides of equation 1 to the fourth power, right? You can go ahead and try that. I'm not going to do that. Right, I'm going to raise both sides of equation 2 by power 2. That is, raise both sides of equation 2 to the second power. So let's start off with that. So from equation 2, maybe let me just put it down here, equation 2, right? So I'm going to raise the left-hand side, which is x squared plus y squared plus z squared to the power 2. Noting that when I raise it to power 2, I will still have some fourth power terms. So I'll raise that left hand side to the power of 2, and then raise the right hand side to the power of 2. So this is 9, you raise it to the power of 2 as well. Good. So let's expand the trinomial on the left. So when we expand this, we're going to get the one I'm going to write down. Actually, I'm going to expand it right here, but I just hope I will not get it out. So this is going to be x to the fourth power plus 2x squared y squared, okay, then plus y to the fourth power. Good. That's not all. Then we have to continue, but this is going to be 2 times x squared z squared plus 2 times y squared z squared, and then plus y to the fourth power, plus z to the fourth power, and then we equate this to 81 on the right. So that's what we get when we expand that, hopefully. Okay, that's nice. So we notice that we have what we want, the x to the fourth power, the y to the fourth power, and then the z to the fourth power. So we just have to put those 3 down, and let me put them in red. X to the power of 4, and notice that everything is added. So y to the power of 4 plus z to the power of 4. Good. And then we want to make this a subject. In other words, we're going to subtract every other thing from the right. Good. So that means it's going to become the 81 minus this term, minus this term, and minus this term, right? So you notice that 2 is a common factor in each of those terms. So I'm going to factor out the 2. You're going to have x squared y squared plus x squared z squared. Okay, then plus, you notice this one, y squared z squared. Okay, great. So our aim now is to know what this sum is. What is x squared y squared plus y squared z squared plus x squared z squared? When once we are able to know what the sum of these 3 is, we multiply that by 2 and we subtract the result from 81. That will give us the answer to the question. So in fact, let's just get into it. Okay, so let's see. Well, how can we get x squared y squared plus x squared z squared and so on? Remember, we were in search of we were searching for x to the fourth power this term, and we were able to get it by raising this equation 2 to the power of 4. Maybe let's start off with equation 1. Let's raise equation 1 to the power of 2 because we need some square terms. Let's hope that this will come out, or we'll be able to get it, right? So let's start off with equation 1. So let me just put it down here. Equation 1, we have that x plus y plus z is 3. So we're going to raise both sides of equation 1 to the power of 2. So we raise this to the power of 2, and we raise 3 to the power of 2. Of course, that's just 9 when we raise 3 to the power of 2. Okay, great. Now we raise the left hand side to the power of 2. That's a trinomial. Let me write it well for you to see. Then we raise this one to the power of 2. Okay, like I said, so this right here is a trinomial. So similar stuff here, but this one is just with a single powers. So this is going to be x² plus 2xy plus y squared plus, let's see, this should be 2x this should be 2xz plus 2y, am I getting it out, 2yz, okay, plus z squared. So what I'm doing here is that I squared this term, x² plus y squared plus 2xy. Then we now take 2 times this sum plus times z. That will be 2xz plus 2yz, then plus z squared. This right here is equal to 3 squared, which is 9 on the right hand side. Good. Okay, so we notice that we have this term. Though this is not what we want, because we know this one already from equation 2. X² plus y² plus z squared is equal to 9. So we just pull all of them together. So that is x² plus y², sorry, that's y², okay, plus z squared. This right here is known from equation 2 as 9. Then we need to add this to that. So you notice that what we have to add has a factor of 2, or these things have 2 as their factors. That is as a common factor. So we're going to factor out the common factor. I will be left with this sum, and the right hand side is still going to be 9. So notice that this one alone, from what I said, is 9. So notice what we have. This is 9. We are adding something 2 times each of these. That is 2 times this sum. We're adding it to 9, and the answer is still 9. It means that this right here must be 0. Okay, that is, it means that 2 times xy plus xz plus yz has to be 0, because we are adding 2 times of that to 9, and then we get 0. Sorry, and we still get 9. It means that this right here must be 0. Okay, so since this is 0, maybe I can just divide both sides by 2. That is, this sum is 0. So notice what we want. We want the sum of the squares of each of these terms. And these are the terms, but they are not squared. So what if we raise it to the power of 2? So we raise 0 to the power of 2. Let's expand what we have on the left to see what we get. Good. So I'm going to expand this right here. It's still a trinomial. So x² y² plus, so this will be 2x² yz plus, let's see, that will be x² z², okay, then plus 2x y² z plus 2x y z² plus y² z². Okay, we equate that to 0 squared is just 0. So what I've done here is that I've expanded this trinomial on the left. Well, it may not really be that easy to expand a trinomial, because you're supposed to have so many terms. So maybe you have to do this little by little, right? I don't just want to go through the whole ground process, but it's easy. Good. You can use the trinomial formula or use the binomial formula. If you want to use the binomial formula, this is what I'm doing. Group these first two as one term, and then this one as the second term, and you're going to get this, all right? I hope I've not made a mistake as well. Okay, so we notice that what we want is out. This is it right here, and then x² z², and then y² z². That's the sum we are looking for. So maybe let's group each of those terms that we're looking for together. That is x² y² plus x² z² plus y² z². And then notice this, what is left. Maybe we can move it to the right hand side at the same time. So we move this to the right. Notice that there is a common factor among these terms. The common factor is 2xyz. Each of these 3 terms has 2xyz. So we move it to the right. We're going to turn it to minus 2xyz. And then inside the bracket, we'll be left with x here, because there are the factors. X appears twice in this first term. When we factor out 2xyz, we'll be left with a single x right here. Then for this second term, we'll be left with a single y. Okay, maybe let me just put it down here so that we'll be able to see what I'm talking about. So this is 2xyz into x plus y plus, for the last term, when we factor out 2xyz, we'll be left with a single z. Good. This minus sign is because we've moved it to the right. And there's no 0 on the right hand side, because we've added this negative 2xyz times this factor to 0. Okay, so this tells us that this right here is equal to this. But do we know what this is? Well, take note that from equation 3, x, y, z is minus 1. Of course, we've not used equation 3 since we started, so we have to make use of it, right? So this tells us that this left-hand side, since this right here is from equation 3, this right here is minus 1. So x, y, z is minus 1. We multiply minus 1 by minus 2, all right? So this is minus 2. We multiply by minus 1. And then this bracket, this sum of three things, is given as 3 from equation 1. So that means we're going to also multiply this by 3. So this is negative 2 times negative 1 times 3. That's just positive 6. So what that tells us is that this right here, which is what we have here, is positive 6. Who? Isn't that very nice? So what we just have to do is this 6, that is the sum of these three terms, times negative 2, that will be negative 12. We subtract 12 from 81. That will be 69. So that tells us that I don't want to clean since I've gotten to this point. So after everything, everything here will give us, okay, I hope that's nice, will give us 69. And that's right there is the value of x to the 4th power plus y to the 4th power plus z to the 4th power. I hope that shows very well. Okay, 69. Yeah, so you've seen that. I know the answer doesn't look nice after so much work, but of course that's how life is. Sometimes you put in so much work and you don't get so much, but of course I don't wish that to you. Anyway, thanks for watching. Please, I hope you like the video. Please subscribe to my channel, follow my page, share this video with your friends, and we'll continue for our next video.